Welcome, learners, to this chemistry lesson for the day, coming to you live from the UPA Command Center at the Top Notch TV. The teacher of the day is Martin Bunguswa. Today, we present to you the laboratory preparation of alkanoic acids. This is a homologous series of compounds that have a general formula of CnH2nCOOH. Now, alkanoic acids are prepared by oxidation of corresponding primary alcohols using acidified potassium manganate 7 or acidified potassium dichromate 6. When we were learning about preparation, about the chemical properties of alkanols, you remember we said that alkanols can be oxidized using permanganate or dichromate to form carboxylic acids. And now this is the method that we're discussing today. The setup that is used in the preparation of carboxylic acids is as shown on the screen. You have the Liebig's condenser, you have the water in, the water out, then we have absolute ethanol placed in a flask and mixed with potassium dichromate 6 and sulfuric acid, which is dilute in order to acidify the medium. The mixture is distilled. It's just like distillation process. And ethanoic acid, having boiling point of about 100 degrees Celsius, distills off. The equations for the reactions that occur in the flask are as shown. And you'll observe they are exactly the same properties that we have discussed under the alkanols. So as we continue learning, each one of us should be able to relate what they have covered earlier and how it relates to what you're covering currently. When potassium dichromate is used in that experiment, there'll be the change of color from orange to green. And that is the only way we can ensure that a complete oxidation has actually taken place. So if I oxidize ethanol, I get ethanoic acid. If I oxidize propanol, I get propanoic acid. If you oxidize butanol, we get butanoic acid. That is how clearly the alkanols are prepared in the laboratory. You notice not a very complicated method. Now, the alkanoic acid that you have prepared using any of those methods have the following physical properties. Remember, most of them are colorless liquids. Just like the alkanols and other compounds that we have discussed before, we notice from the table we are displaying on the screen that the boiling point of alkanoic acids increases with increase in the molecular mass. This is because of increase in the number of van der Waals forces as we move down the homologous series. But you notice that the state at room temperature of most alkanoic acids is that they are liquids. The first three, methanoic acid, ethanoic acid, and propanoic acid, are very soluble in water. The others are also soluble, but their solubility is slight as compared to the first three. Meaning, as the number of carbon atoms per molecule increases, the strength of the intermolecular forces also increases. The boiling points of alkanoic acids is usually higher than those ones of alkanes, or with almost equal molecular mass. The reason is because just like alkanols, alkanoic acids have what we call hydrogen bonds, and also they have van der Waals forces. But the hydrogen bond is usually more stronger than a van der Waals force. The alkanoic acids have a higher melting point and boiling point than corresponding alkanols, simply because of the number of hydrogen bonds. The hydrogen bonds have equal amount of strength, but you notice that in a carboxylic acid, the hydrogen bonds are much more than in an alcohol. If we pick on a molecule of ethanol, for example, there is only one hydrogen bond. But if you take ethanoic acid, it exists as a dimer with two of those forces. Solubility in water decreases with increase in molecular mass. So one thing, learners, you are discovering here is that the properties of alkanoic acids and the properties of alcohols are almost the same. The variation is only because of the change in the number of the carbon atoms that we find in our structures. Those are what we call the alkanoic acids. That's how they are prepared, and those are the physical properties. More other examples of how they're supposed to be prepared, please, we have agreed that you make this book to become your handbook, so that on each and every item that you are discussing, you can always find it inside this book. Also, there is another one called the Guru. Now the Guru is giant. All these others can all fit in the Guru, and you'll find it a very good companion for your revision work. At Top Notch, we try to bring out the knowledge of chemistry in an ocean, not a lake.